Hey, and welcome to us doing some trigonometry here. So these questions, at least the first two pages, are going to heavily build off of using this sum and distance formula, these two formulas right there. And what we're going to be really doing is spending a lot of time identifying like what angle is the alpha and then plugging it into the correct places on the formulas. And really, these questions are very formulaic. Sometimes you have to get a little bit creative to think about how you're going to apply the formula, but largely it's just going to be a lot of crunching some numbers and then filling in the gaps of what you're missing. So I guess let's take a look at some of these and how they're going to play out. So this first one actually is one that we can do a little bit of computation with. So let's start by identifying what our alpha and what our beta angles will be. And so my alpha is going to be x. So my alpha angle is x. And my beta angle is going to be 90. And then so this is sine. So that means it's going to be using this formula. And so that's what we're going to start with. We're just going to plug these values in and see what this all evaluates to. So it's going to start with sine of the alpha angle when the alpha is x. So we're going to say sine of x, followed by cosine of the beta angle, now we have to check to see what the sine is, because whatever the sine is here, we have to match it as we're connecting in there. And we can see that the sine here is minus. So we're going to put a minus sign there, followed by cosine of alpha and sine of beta. And then at this point, we've got it set up, and all we've got to do is evaluate. I say I wrote beta there instead of 90. So let's just take a look at what cosine of 90 would be. So cosine is the x values on the unit circle. 90 degrees is up here at the top. And so that point is 0, 1. So the x value there is going to be 0. And so that's going to turn into 0. And then we have sine times 0. So sine of x times 0 is just going to be 0. So that entire term ends up just canceling out. Minus. And then we're going to evaluate sine of 90. Well, that from our unit circle, we're going to know that that's going to be 1. And so then cosine times 1 is just still going to be cosine. And so that is how, with this question, we end up with negative cosine. And that's what we were looking for there. All right, let's move on to the next question. This one has two cosines that we're going to have to end up working through. And I'm going to put the formula there so that I can remember what it is. Again, these are just incredibly formula heavy. So this is, if we have cosine of alpha plus or minus beta, that's going to turn into cosine of alpha, cosine of beta, and then we have the minus plus, which basically means do the opposite of whatever sign we had here. Sine of alpha, sine of beta. All right, so we've got to do this twice, basically. So we've got plus alpha is x, beta is y. So this first piece, we're going to jump right into saying cosine of x oops, cosine of y. And then it's the opposite of that sign, so this is going to turn into a minus sign. And we're going to have sine of x and sine of y. Then we continue, so we're going to do the next part, so plus, and now we're on the next expression here, which is the same as this, but it's going to have an opposite sign, so I can, quickly just fill this out. So because this is x minus y, we have the opposite sign placed here. And at this point, we're really just looking to combine like terms or potentially cancel things. So I have an entire term of negative sine x times sine y, and then I have a positive version right there. So those two things are the same term, except for this one's negative. So we're able to cancel those two things out. And then the only thing left is the term cosine x cosine y and the term cosine x cosine y. So we can add those two terms together, and then we end up getting 2 cosine x cosine y. And that is what we were looking for. All right, let's move on to the next page of problems that had a little bit higher density of stuff. So these ones still continue to build off of that same usage of the formula, except for now we're kind of plugging in trig values, and we might have to do a little bit of trig manipulation to get there. We want to find cosine of alpha minus beta. So that tells us we're going to be using the cosine version of the formula. In the cosine version of the formula. So cosine of alpha plus or minus beta is equal to the cosine of alpha times the cosine beta. Then minus plus, so the opposite of whatever was inside of there. Sine of alpha, sine of beta. And then what we're going to end up discovering during this question is we may not have all of the pieces that we need in order to solve everything. So let's plug in the formula and see what we're missing. So the formula is going to turn into cosine of alpha cosine of beta. And then we do the opposite of the sign that we saw there. Sine of alpha, sine of beta. So we know some of these. We have sine of alpha, and we have cosine of beta. But we don't have everything else. So really the easiest approach that we can do that is to apply the Pythagorean rule. So we know that if we have sine squared plus cosine squared, that would equal 1. So we're able to figure out what basically sine of alpha here would be. I'm sorry, cosine of alpha by using this formula. So we could go and take and put sine of alpha squared plus cosine of alpha squared equals 1. And I'm going to algebraically solve it a little bit to see what we end up plugging in. We want cosine, so that's going to basically mean that cosine of alpha will be equal to the square root of 1 minus sine of alpha squared. And that's going to be basically what we end up doing for the other one. So we know sine of alpha was right here, so we're basically evaluating 1 minus 12 over 13 squared. Now, I think that's a job for a calculator, so we're just going to use GeoGebra. I would use Desmos, but Desmos isn't very friendly with fractions. So we can actually just punch this in here. Oof. Well, that's not being very friendly with fractions either. And then we just know the square roots of that. So that was the square root of 25 over 169. So we know that cosine of alpha is equal to 5 over 3. Now, in retrospect, there might be an easier way to do that. Noticing that this is basically the sides of a triangle, we could probably save ourselves the headache and just use our knowledge of right triangles. So I would know that the corresponding sine of beta, that if I have a triangle of what is cosine? Cosine is adjacent. Not that it really matters. Adjacent over hypotenuse. So if we have 3, this is obviously for a 3, 4, 5 triangle. And so sine of that same angle is just going to be 4 over 5. All right, so now we have all the pieces we need to be able to plug all this in. We have cosine of alpha, which is over here in this dark purple. Cosine of beta was one of the givens. Plus sine of alpha was given. And sine of beta was one of the ones that we figured out over here. And then at that point, we get sad because we actually have to do a little bit of math here. Let's see, that would be 63 over 65. And I'll double check it just to make sure that my math was correct. Okay. So that is the answer that I would go with. So you're going to see this pattern end up being repeated quite a lot as we're trying to figure out the pieces that we might be missing.